And I don't know that it actually started recording yet until I hit it. Okay, pretend that you didn't hear this already. Yes. We are starting a review. 1.3. We just went back and did a problem that was sketch an angle theta in standard position such that theta has the least possible positive measure and the given point is on the terminal side of theta. Then find the values of 6 trig functions for each angles, rationalize each in the denominator. So this is a problem we did. You missed Tyler singing all of the answers. I apologize. It was beautiful. Maybe he will keep continuing and blessing our ears with more singing.
I will.
So, that's one problem. What happens if you have a point 1 square root of 3? Can you plot that point, draw your theta, your angle, and then find all 6 trig functions? Which quadrant are we in? Quadrant 1. So question, will everything be positive? Yes. So if we go over 1, a little exaggerated of 1, and do you know square root of 3 is approximately 1.7. It's less than 2. How do you know it's less than 2?
Because square root of 4.
Because the square root of 4 is 2. So it doesn't.
Have you never been in a math class before? Roughly graph it as like 3 or something like that. Does
I mean, just put the square root of 3. I don't know where the square root of 3 is. I know that I'm a little higher up than I am over, even though I kind of drew them there. Does not have to be perfect to scale 1.73. So your angle theta from standard position up is right here. So your x is 1. Your y is square root of 3. Can you find your r?
Yeah.
Yes, you can. Yes, you can. So what is your r going to be? 1 and 2 square root of 3. So what is sine? Theta.
Why not now? Go on, Tyler.
Is everybody waiting for Tyler to answer? Is that
Well,
Yeah.
the last problem he's saying every answer to us.
Hey, carry on, Tyler. I mean,
Come on,
It's like, of course, Mr. Jesus is walking right as I'm. I mean, it's. Hold on. Let me finish my work over here.
Finish your
it
answers.
doesn't,
I
it doesn't
correct.
have to rhyme, Tyler.
It's okay, we'll wait. Really?
So does everybody have an answer?
All right.
Do you have an answer? Okay, you're starting with them. You got sine. Okay, sine is
Square root of 3 over 2.
3 over 2.
I can't remember how I did the first time. I was like trying to.
There weren't square roots in the first
I
one.
know, so it doesn't flow.
Yes. What is cosine theta?
1 over
Tangent theta.
square root of 3.
Simply square root of 3 over 1. What about cosecant theta? That's a C.
Long square root of 3 over 3.
Over 3.
That was a good one. That was a good one.
You had to rationalize.
Yeah, I like that one. I like that.
Good job rationalizing before you give it to me. Secant.
Square root of 3 over 3.
What?
That's
Secant?
not
We're gonna have to do a callback.
Hold up. Oh, that was wrong.
That was, I think
That
you
was
went
really
ahead and
wrong.
gave me cotangent.
Oh, yeah, I gave you cotangent.
Yeah.
Me too.
Secant is simply just 2.
Nailed it.
Cotangent theta.
Square root of 3 over 3.
So we didn't have to think of any negatives because they were all in the first quadrant. Are we okay? Can you plot them? Can you find all 6 trig functions? You're finding the r's. You feel comfortable doing that?
Yes.
All right, let's move on to another. Can you find?
You're welcome for serenading me, Mr. Sheets.
Good job. I feel like I've been in a arts meets math kind of thing.
Yeah.
Yes. So you just heard Mr. Sheets coming into class and listening to Tyler.
I want to go back and listen to this.
So
I'll
it's
make it
all-
help for all of you.
like make it your ringtone.
If you are in quadrant 4, what will your y over x? Will it be positive or will it be negative? And this says suppose that the point x, y is in the indicated quadrant. Decide whether the given ratio is positive or negative. Drawing a sketch may help is what this says. So y over x. Which quadrant? This is the one that we talked about. It is quadrant 4. Will y over x be positive or negative? Negative. Then your x will be positive, y will be negative. So that result will be negative. Very easy if you know what we're asking. Okay? You have a couple of those problems. Ooh, the one where it gives you a line. If you're given 3x plus 5, well, no, let's do a different one. I like negative 5x plus 3y equals 0, or x less than or equal to 0. Can you graph and then find all 6 trig functions? I'll read the instructions. This is an equation of the terminal side of an angle theta in standard position. It's given with a restriction on x. Sketch the least positive such angle theta and find the values of the 6 trig functions of theta.
Wait, isn't that not because it has to be less than and isn't
So x can't be negative? You can't plug in a negative 2 there and get an answer?
Oh wait, don't you like solve?
Yes, solve. What are you solving for?
Oh wait, don't you? Yeah. So
Y
you go
equals-
So you add the 5.
You add the what?
Wait, are we not doing y equals mx plus
Yes.
Yeah, so you add the 5x.
Okay, 5x.
Yes.
So 3y equals 5x.
So then you divide by 3. So y equals 5. So.
So graph that. Can you plug in a negative x?
Oh, I thought you meant x couldn't. Might be.
No.
Might be.
It just there's a restriction on what x is at. So where's the line? Y equals 5/3 x. We're starting at the origin, and then we're gonna do the 6 trig functions. Yes. So then from there, should we go up and to the right? So we could go up 5, 1, 2, 3, 4, 5, and over 1, 2, 3. We're gonna pretend that those were 1, 2, 3. But that question is, that's a line. That x is positive. We want x's negative.
Oh, so we gotta go.
We need to go down 1, 2, 3, 4, 5 to negative 5, and then back 1, 2, 3. Yes, they fall on the same line, but there's a restriction on your x. And find all 6 trig functions. So from this, can you find the point, the p? What is this point down here? We've done a graph. Which order do those need to be in? How many did I go back? So really this point is -3, -5. And then you're drawing your triangle, you're finding your r. And then it's the exact same problems that we did earlier. The only thing that's different is what you started with and which direction you're going. And this one is not going to work out nice and pretty. You might start to think, oh, it's a 3, 4, 5, but it's not because the y is 5. And the x is -3, so your hypotenuse has to be bigger. It's something like the square root of 34. Please don't add 25 and 9 and get anything but oh yeah, it's 36, and that's 6. Because they want it to be 6, but it's not. It's the square root of 34. Which doesn't make your trig functions be very pretty. So, trig functions, here we go. Let's erase some of my extras. Because I don't need that spot anymore. So, we're writing sine theta, that is all the way over here, is what? Your theta is here. Y over square root of 34, y over r, which is negative 5 on the square root of 34 over 34. Yeah, I don't think that's working anymore. Cosine theta. Negative 3 on the square root of 34 over 34. Tangent.
5.
Is it a surprise that tangent is positive and the others are negative?
No, because
No.
it's in the
You were
third
expecting
quadrant.
You were already expecting that cosecant theta after I put theta there.
Oh, that is square root of 34 over negative 5.
Secant theta.
Square root of 34 over negative 3.
And cotangent.
3
That range.
I can switch octaves.
Yay.
I think that's
Alright.
Wait, I know.
Yes. Positives, negatives matter. Alright. What about quadrantal angles? What about an angle that lies on a quadrant? What is sine of 270 degrees? Sine of 270 degrees. So if you're going around to here, this one says something about sketching the graph. Begin by reproducing the graph on figure 29 on page 25. Keep in mind that for each, the 4 points labeled on the figure are equals 1. So I might ask for you to graph and plot a point here of 0, negative 1. So I'm going to ask you to identify the x and the y and the r. So your x is 0, your y is negative 1, and your r is 1. Sine, again, is dealing with a y. You need to draw that triangle. It's okay to draw a triangle and just pretend that it's like dot over here, 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 your r, x, and y. You need to draw that triangle to see opposite over hypotenuse, y over r. So sine 270, I agree, is negative 1. There really is only 3, but other than 10. If you have sine or cosine, your options are 0 or 1 or negative 1. Yes, ma'am.
So the reason it's asking us to graph is just to see the point. So we can still type in our calculator and then operate on the
Yes, please check those in your calculator. Quadrantal angles will generally always be a nice, pretty number that you can check in your calculator. Yes. It's not cold. So then, can you find if I give you something like 3 secant 180 degrees? 3 secant 180 degrees plus 5, 10, 360 degrees. I would rather you not plug it in your calculator. I want to see what you get for. Okay? Because there are going to be times that you are not allowed to use your calculator. You should not. And then I will tell you not to sometimes. You need to be able to do this. And then it's funny because my calculus kids are already like, when are they doing this? When are they going to make the posters? Because I need to see them. And then when we make posters, there's always some in my room, and you get to look at them, and they are beautiful and wonderful. And we will say, in the middle of the test, you're gonna turn around and you're gonna look at the poster and say, and find that answer. Okay? But right now they're not there. It's second quarter. It's our second quarter project, but calculus is ready for you to have them because they've got trig stuff that they need those for. So, secant 180. Where are we? 180 degrees. It's the inverse of cosine. So this is -1, 0, or r is 1. And I'm pretty sure sine is dealing with y, cosine is dealing with x. So it's still 1 over -1, or -1 over 1. So do we all get -1 for secant of 180 degrees?
Yeah.
And maybe you didn't or don't remember how we put that in our calculator, secant. Yes, ma'am.
All of the fractions gonna be in between -1 and 1? Or all of them, like tangent versus
We're always going to use these points for quadrantal angles. We will always use these one away points.
just for right now. It's okay. It's gonna be -1.
1 or 0. -1, 0, or 1. Except our tangent is undefined at points. And secant and cosecant are undefined at certain points.
So
Okay?
if you plug it in your calculator, it'll tell you.
Well, it'll say error.
It'll say
It'll say error.
Yeah.
Yes.
I don't understand.
So we are looking at a point. Where's 180 degrees? We knew we went all the way over here. Okay? And there we plotted a point. The first time we did it, we plotted like 4, 0. Okay?
You can do it.
We can do it with any numbers. The issue is they always reduce to 1 over 1. 4 over 4, 6 over 6, 72 over 72, they will always reduce to 1. Okay? So the easiest thing to do is use 1. Okay? And that will get us into, later we'll talk about a special circle that has a radius of 1. That's why we go there. Okay? Now, secant is the reciprocal of cosine. So really I'm looking for, what is cosine of 180 degrees? So if you need to see a triangle where x, goodness, stop, where x, y, and r. Okay, so your x is -1, your y is 0, and your r is 1. What is cosine of theta? X over r. So x is your -1, your r is 1. When we reciprocate that for secant, it's still 1 divided by -1, which is still 1. -1. Does that make sense? Okay, so now we're going to multiply it by this 3 that's here. So 3 times -1 is simply just -3. Okay? What about tangent of 360? I'm going to go draw another spot. Where am I at for 360 degrees? I'm going all the way around. Whoop, and I'm back to there. That kind of looks like a G. Oh, take that off. So I'm over here. So what is that point? It's going to be 1, 0, and your R will be 1. Well, what is tangent if you need to look at a triangle? X, Y, and R. It's Y over X. So it's Y over X, which is 0 over 1, which is 0. So what's 5 times 0? Your answer is, please don't say negative. Your answer is -3. Okay? What do you mean fractions? I mean, all I did was opposite y over x. So I just did 0 over 1, which is just 0. Just to show Molly that that's what it was. Tangent of 360 will be 0. No matter what, if you plugged it in your calculator, it's going to be 0. But why is that? Because it's y over x. It's 0 divided by 1. All trig functions are ratios. They're actually the trig ratios. Sine is opposite over hypotenuse. The ratios. No, that's why I drew a triangle. Number one, is because somebody else asked me to. How do you see this if you don't have it memorized? Yes, the sad thing is I have them memorized. But theta, opposite over adjacent, means it's the total.
But if the point is on the line, then how do you know which way to draw the triangle? Like,
Well,
why?
even if I did it this way,
Yeah.
it's still y over x. It's still y over x. And that's all I'm doing. Because y is 0. There's not a triangle really there. That's the issue. You're trying to see something that does not exist. It's flat. It's flat and it's not there.
Is that why it equals 0?
Yes, that's why y is 0. Your y is 0. I'm just drawing a triangle so you can see that it's y over x. The triangle does not exist on quadrilateral angles. It's a flat line. Yes, sir. Yes.
It's good.
Alright, you're welcome. Alright, so are we okay? You don't really draw these triangles, but if you can't remember y over x, draw it to see opposite over adjacent. Okay? It's okay to do that. I mean, like this, we know that this y over here is 0, but we drew it so we could see x over r. Because we know that it's flat. Hopefully you know that that's flat, that there is just a line. Okay? I think this is the last on this section. That was 1.3. Woo, we haven't even gotten to 1.4. So that's what we did most recently. This one's been a while. Okay? Hopefully you're looking at your homework. If you have, these I think are way too easy. Use the appropriate reciprocal identity to find each function value. Can you find secant theta if cosine theta is 5/8?
Wow.
I think that's probably going to be the easiest question on the test.
Is it
8/5. Very much so.
I'm sorry. I remember.
Okay.
That was a weird.
We all had
Determine.
peppermint macchiatos. Yeah, I had some good coffee. And you guys are
Determine the signs. Can you determine the signs? Yes, I'm cutting you off because we're almost finished. If you have an angle that is 178 degrees, if your theta is 178 degrees, what are the signs, positive or negative, for all your trig functions? First off, which quadrant are you in? You have a theta of 178 degrees. What quadrant are you in? 2. So you're in quadrant 2.
Barely.
So right here, yeah, only 2 more degrees and you're not. So you're in quadrant 2. So what is positive in quadrant 2? Sine and cosecant are positive. Everything else is negative.
So it's just asking for what would be positive.
Mm-hmm. Is to determine the signs, positives or negatives. Okay? Can you find which quadrant, if you're given sine theta is greater than 0? If sine theta is greater than 0 and tangent theta is greater than 0, what quadrant are you in? You have to be in quadrant 1. The only 2 places where everything is positive. If I gave you, let's see, cosine theta is less than 0 and sine theta is less than 0. Right now,
Three.
You're in 3, where tangent is positive.
I thought tangent was positive, right?
So that's 3, that one was 1. Now, can we use identities? The only one that I would ask you is, so you know, sine squared theta plus cosine squared theta equals 1. So if it says use an identity, you know you're going to be using this one, other than the reciprocal identities, those are just automatic. If sine theta equals 1/2, what is cosine theta? Use an identity. So I would need you to plug it into this and not draw a triangle. I gave you the formula.
Well, yeah, but like. We have our notes. Okay. So wait, okay, question. Do I square the 1/2 first?
Okay, PEMDAS. PEMDAS says what?
Parentheses, exponents.
Exponents. Most definitely.
Excuse my dear Aunt Sally.
1/2 squared plus cosine squared theta equals 1. And if you were with Dr. Hearns, you would have said this. Cosine, actually she would probably say cosine theta equals the square root of 1 minus sine squared theta. With your plus or minus. You guys are not in physics.
Nope.
Oh my goodness, this is brand new to me. You're not in physics. So when I say Dr. Hearns would do it this way, I don't have to say that anymore. So I would never do it that way. She rearranges and then plugs in numbers all the time. We've had this conversation. She says, "Why do they not?" I said, "Because I don't do it." And that's just it. I plug it in and then I say cosine squared theta equals 1 minus. We all know 1/2 squared is 1/4. Then I also, because you're juniors and you're smart enough, I skip some steps. Yeah, so I'm going to go ahead and say cosine theta is the square root of 3/4. So I took the square root, subtracted, and took the square root at the same time. But I still need my positive or negative because you needed to be given one more piece of information. What quadrant is this in? Because we don't know if it's supposed to be positive or negative. If sine is positive, which quadrant could it be in? 1 or 2. So we're going to go ahead and say it's in quadrant 1. So that we will take the positive. Okay? So what is our answer? When we take the square root, what are you left with? There you go. Okay? Using an identity, the only one that I'm going to ask that you know is sine squared plus cosine squared equals 1. We'll deal with the other ones another day. All right.